For this one, evaluate this. First of all I do is I put equals something, and then I rewrite it as an exponent. So to rewrite it as an exponent, I cover up the log, and then I switch these two. Again, I cover up the log, switch those two, and from there you look at it and you just use your brain and go, okay, 4 to the what power is 64? You should hopefully understand it's 3. 4 to the third power is 64. On a benchmark, these will always be a whole number of some sort. Number 2, we want to rewrite it as a log. So to rewrite this as a log, basically you write the word log in front. The 7 becomes the base, and you switch these two. Again, you write the word log in front, and you switch the x and the 11. There's your answer. Number 3, I want to find this using these two values. So somehow I have to, with 63 here, I have to make 63 using 7s and 3s. Somehow using 7s and 3s, I need to make 63 by multiplying them in some fashion. So, instead of log 63, I'm going to break it down into a couple numbers multiplied using 3s and 7s. What would it be? Hopefully you realize, isn't this 9 times 7? And isn't 9 3 times 3 times 7? What you have to do is you have to look at 63 and realize it's 3 times 3 times 7. Now if you struggle with that, do you understand you could have done a diagram like this and done this and keep breaking it down? Does that help? Do a little tree. Now how does that help? Why does that mean anything? Well, remember back to log properties. A multiply means add. So this multiply means add, and that multiply means add. So I can break it down 3, 3, 7 as plus, plus. And then, what's also kind of weird here, is you could also, look at this. Do we know the value of this one? Isn't this 0.5? Isn't this 0.5? Isn't this 0.8? Do we know the values of each of those? Can we now add them all up and get our answer? We didn't know the value of 63, log 63, but we knew the value of each piece, and we can create it using our log properties. When we add all this up, you get 1.8. So log 63 would be 1.8. And the last one, number 4. I want to expand this. In order to expand this, you have to remember divisions are minus, multiplies are add, and powers go to the front. So the first thing I'm going to do on this problem is I'm going to separate everything into 3 pieces. You'll see it right here. You got to keep the log base 6 also. Log base 6. We start with x to the 5th. Now, do you understand the 7 is on the bottom? Didn't we divide by 7? So divides are minus, so this is going to be log 7. Isn't this y to the 4th also on the bottom? X to the 5th was divided by 7 and divided by y to the 4th. So we're going to minus log, oops, I forgot my base 6. It's so easy to forget them. Don't forget base 6 for all of them. Y to the 4th. Again, don't forget the bases. So again, the 7 and the y to the 4th are both minuses because they both were divided by, or divided from x to the 5th. So basically, if it's on the bottom, it's a minus because it's divided. Now the last step is all powers go and take a leap off the log. So you take this guy and move it out front. 5 log base 6x. This has no power, so it stays the same. This 4 comes out front. And then, do we know the value of log base 6, 7? No. That is expanded. We are done.